A single typhoon took more than 1,400 lives, so Japan drove a railway 240 meters beneath the seafloor, stretching 53.85 kilometers, refusing to hand life back to the sea. The Alps stood in the way, so Switzerland carved a 57-kilometer straight line through bedrock, turning hours of mountain travel into minutes. Top 10 longest tunnels. Their length is only the surface. What truly matters is why they had to exist. Number 10. Yamate Tunnel, Japan. Tokyo's surface ran out of room long ago. Buildings, subways, water mains, fiber optics, and power cables layer upon layer. Inside this airtight city, engineers decided to go deeper and place a highway even further below. This is the Yamate Tunnel, 18.2 kilometers long, running through central Tokyo. It is Japan's longest urban underground expressway. It was born of a contradiction. The surface could no longer bear growth, but the city had to keep developing. The biggest challenge wasn't how to excavate, but how to find a safe path that wouldn't disturb buildings, subways, or groundwater. The team custom-built one of the world's largest dual-shell TBMs. The outer shell cuts, while the inner shell injects grout in real time to stabilize strata, letting the TBM glide past subway walls with millimeter-level clearance. With every meter advanced, sensors monitored pressure and vibration in real time. If deviation exceeded 5 millimeters, the TBM stopped automatically. Construction began in 1992 and lasted 23 years. In 2015, the tunnel was fully opened. The cost exceeded 1.6 trillion yen, about 13 billion USD, and Tokyo's expressway network finally closed its ring. Today, 400,000 vehicles travel underground daily. On the surface, you can't see it or hear it, but because of it, the megacity of Tokyo keeps running quietly. Number 9. Lærdal Tunnel, Norway. If you drive 20 minutes straight in the dark, your sense of time collapses. The designers of the Lærdal Tunnel knew this. In western Norway, mountains cut off traffic between fjords and winter avalanches erased roads. To fix it, they decided to build a road tunnel through the mountain. The Lærdal Tunnel, 24.5 kilometers long, linking two valleys sealed by snow. Scientists found that in prolonged monotony, people lose their sense of direction and time, so to keep drivers awake in the dark, they deliberately gave the route a slight curve, so eyes always caught reflections on the walls. Every 6 kilometers, the tunnel suddenly grows bright, opening into a blue and gold cavern that simulates dawn and dusk, waking up human perception. Lighting here isn't decoration, it's psychological intervention. The geology is equally harsh. Granite hard as steel required drill and blast, followed by shotcrete and steel ribs. Costing about 1.1 billion NOK, around 130 million USD, the project started in 1995 and finished in 2000. During 5 years of work, explosions echoed in the mountain. Rock fragments poured from the portal like snow. A massive mid-tunnel extraction plant refreshes the air in 10 minutes. Today, tens of thousands of vehicles pass daily. Drivers can't see scenery outside, but amid blue light and silence, they stay alert. Lærdal isn't a symbol of conquering nature, it's an experiment about human perception. Number 8. Taihang Tunnel, China. On China's map, the Taihang Mountains form a natural wall, dividing the North China Plain from the Loess Plateau. Stretching over 400 kilometers, they once deterred railway builders. To complete the North China high-speed railway loop, engineers decided to carve a passage straight through the mountains, the Taihang Tunnel. It is 27.8 kilometers long, started in 2005, completed in 2007, at a cost of about 3.2 billion RMB, around 450 million USD. The project looked smooth on the surface, but underground it seethed. Surveys showed more than 20 water-bearing faults through the middle section. Hot, high-pressure groundwater meant a normal drive could cause instant inundation when a layer was breached. Engineers adopted the ground freezing method, used for the first time in China's HSR construction. Hundreds of refrigeration pipes were drilled along both sides to freeze fault water into ice walls up to 2 meters thick. Then excavation proceeded within them. Temperatures were held at 30 degrees. It was a race against time. When the tunnel broke through, trains covered the segment out of Shanxi in just 20 minutes. Once it took dozens of curves and 6 hours. The mountain is still there, but it no longer blocks. The Taihang tunnel's meaning is more than passage. It's finding a new way to move between nature and engineering. Number 7. Guadarrama Tunnel, Spain. In central Spain, rail from Madrid to the northern plateau must cross the hard mass of the Guadarrama Mountains. The rock layers are like a torn book, granite, shale and sands stacked in patchwork, making geological maps useless meter by meter. So engineers chose not to guess, but to advance and see. The Guadarrama Tunnel is 28.4 kilometers long, one of the most complex segments of Spain's high-speed network. From the start, they knew this was a war against an unseen enemy. Groundwater could intrude any time, and rock types changed faster than instruments could log. Spain introduced Guadarrama for the first time in tunnel driving. Electromagnetic waves scan ahead of the TBM, adjusting thrust and cut-ahead pressure in seconds. This almost turned the tunnel into a machine that could judge geology on its own. The TBM crossed 17 rock types. Where rock was too hard, daily advance slowed to 2 meters. Driving from both ends, they finally met in the mountain's centerline with less than 8 centimeters of error. After completion, Madrid-Segovia dropped from an hour to 20 minutes, and high-speed trains glided through the northern ranges for the first time. The Guadarrama Tunnel has no spectacular facade. Its achievement sits underground in layers human eyes never see. It proves the hardest obstacle isn't the mountain, it's mastering the unknown. Number 6. New Guanjiao Tunnel, China. At 3,300 meters above sea level, the air is so thin a match barely lights. Yet in this environment, humans cut a 32.6-kilometer railway tunnel, the new Guanjiao Tunnel. It's the longest railway tunnel on the Qinghai-Tibet Plateau and the key to completing the Lanzhou-Xinjiang high-speed corridor. Without it, trains would have to detour. The goal was simple: allow trains to pass the mountains smoothly at 160 km/h from Lanzhou through Xining. Construction began in 2005, totaling about 8.7 billion RMB, around 1.2 billion USD. Here, oxygen is only 60% of sea level norms, and temperatures stay below zero. People and machines both struggle. Welding flames falter, concrete sets slowly, even TBM hydraulic oil gels overnight. To keep work going in low oxygen, oxygen stations were set up. Crews worked in shifts, 40 minutes on, then 10 minutes of mandatory oxygen. With permafrost, faults and water-bearing layers coexisting, a slight TBM misalignment could wedge it in ice. The team re-engineered systems for low-temperature operation and added internal heating loops so machines could run at 20 degrees. Simultaneous grouting stabilized rock, preventing cracks from extreme diurnal swings. In 2014, the line fully opened. The plateau's second rail corridor was through. Trains pass Guanjiao at 160 km/h. Passengers hardly sense they're inside more than 30 kilometers of mountain. New Guanjiao isn't about boasting altitude. It answers a deeper question: how engineering keeps working, where air is thin and cold is constant. Number 5. Yulhyeon Tunnel, Korea. The edges of Seoul look quiet, but underground stretches a nearly endless passage. The Yulhyeon Tunnel, 50.3 kilometers long, is Asia's longest high-speed rail tunnel and the core link between Seoul and Pyeongtaek. The city almost hides it. Trains vanish from the surface, race through darkness 50 meters below, and appear in another city. The reason to build it is straightforward: to route HSR away from dense neighborhoods and ecological reserves. The line had to go underground. Launched in 2011 and costing about 3.7 trillion KRW, around 3.2 billion USD, it proved far more complex below ground. Yulhyeon's geology is loose, riddled with faults, clays, and old river sediments, like driving a TBM through a shifting sand dune. To hold precision, Korea introduced an advanced 3D monitoring system that tracked pressure, moisture, and vibration in every segment in real time, feeding data back each second to auto-adjust the drive angle. Ventilation was designed with bidirectional flow for full air exchange in 10 minutes. Safety passages, substations, and drainage are buried within structural layers. No exposed lines anywhere. Completed in 2016, it became the invisible backbone of the Seoul metro region, letting trains run underground at 300 km/h while the surface stays calm. Number 4. Channel Tunnel, UK, France. Deep beneath the English Channel lies a tunnel that turned an island into part of the continent. Linking the UK and France, it's 50.45 kilometers long, with 38 kilometers under the sea, the first permanent passage ever dug between two nations. Long seen as a romantic political symbol, bringing Britain a little closer to Europe, two teams drilling from opposite shores to meet under the sea with no more than 35 centimeters of error. Seabed strata, clays, sandstones, silts, are treacherously complex. A slight misread risks collapse or inrush. Millions of liters of seawater seeped in daily. Crews pumped non-stop and kept tunnel air pressure higher than outside to resist intrusion. Cutter heads were tuned to bilateral symmetry, and tiny directional errors were corrected in real time by laser guidance. In 1990, when the two teams met, a British worker reached through the slurry to clasp a French worker's hand. The photo became a symbol of European cooperation. Work began in 1988 and finished in 1994, taking 6 years, at a total cost of about £9 billion, around 15 billion USD. This tunnel was never just construction, it was a test of trust. Today, hundreds of trains pass each day, crossing the border in 30 minutes. Number 3. Seikan Tunnel, Japan. In 1954, a storm called the Toya Maru Typhoon sank 5 ferries in the Tsugaru Strait, killing over 1,400 people. After that night, Japan decided the sea would no longer decide fate. Between Hokkaido and Honshu began an undertaking that lasted more than 3 decades. The Seikan Tunnel is 53.85 kilometers long, with 23 kilometers under the sea. Initial surveys started in 1955, construction continued 24 years, and the tunnel opened in 1988. Total cost was about 6.8 trillion yen, around 6.5 billion USD. Engineers faced not a mountain, but a moving seabed. Volcanic rock, sandstone and shale interweave in unstable strata. Water inflow was routine, collapses common. In 1976, a sudden inrush poured 8,000 tons of seawater in minutes. The workface was sealed and the project paused for half a year before 3,000 tons of concrete sealed the breach and digging resumed. The deepest point lies 240 meters below sea level, where pressure equals 24 tons per square meter. To keep workers alive, they built pressure-tight chambers. Each entry and exit required a 40-minute decompression cycle. When trains first ran in 1988, the undersea crossing took 25 minutes. There was no sea to see, no wind to hear, just car lights swaying in the dark. The Seikan tunnel finally bound Honshu and Hokkaido and stands as a monument to those lost to the sea and to the human refusal to be defined by nature. Number 2. Gotthard Base Tunnel, Switzerland. To cross the Alps, Switzerland spent a century. In the 19th century, they built the first Gotthard tunnel. In the 20th, the motorway. In the 21st, they decided to dig again, this time through the mountain's base. The Gotthard Base Tunnel, 57.1 kilometers long, is the longest base tunnel in the world, letting trains pass the massif at 250 km/h on the level. Work started in 1999, finished in 2016, costing about 12 billion Swiss francs, around 13 billion USD. This wasn't just engineering, it was a trial of time and precision. Crews worked around the clock, rock temperatures hit 45 degrees 6, and rock pressure could crush metal conduits. Workers called it the Earth's pulse, because after each blast, the mountain trembled for minutes. Driving advanced from 4 headings with only 8 centimeters of alignment tolerance across over 50 kilometers. To fight geothermal heat, they installed recirculating cooling to keep air at 28 degrees. To prevent collapse, they used lining up to 40 centimeters thick. In all, 28 million tons of rock were excavated, the mass of 5 pyramids. On Breakthrough Day, trains nationwide paused for 1 minute in tribute, not just to a tunnel's birth, but to an obsession with perfection. Gotthard made Switzerland one body across the mountains and cut an hour from Europe's north-south rail. Its significance goes beyond engineering, a passage carved by time itself, making the mountains yield to speed. Number 1. Delaware Aqueduct, United States. New York drinks enough water every day to fill 2,000 Olympic pools. Few know where it comes from. It flows along a current hidden 200 meters beneath the surface, the Delaware Aqueduct. At 137 kilometers, it is the longest continuous tunnel in the world and the longest underground water supply system humans have built. It draws from the Catskill reservoirs of upstate New York, passes through limestone and granite, and delivers clean water to 9 million people. Work began in 1939, water flowed in 1945. The cost was about 160 million USD, about 3 billion USD in today's money. The tunnel runs entirely by gravity with no pumps, delivering 4.5 billion liters per day, the equivalent of 1/800 Olympic pools. In the pre-TBM era, crews used explosives and hand drills, clearing hundreds of tons of rock after each blast. The tunnel averages 200 meters deep and maintains a 0.03% downhill grade, almost imperceptible, but enough to keep billions of liters moving day and night. Decades later, as the city grew, this underground artery aged. By the late 20th century, it was leaking over 700 million liters daily, about a fifth of New York's consumption. It couldn't be shut down. Engineers devised an unprecedented plan: repair the tunnel without stopping the water. In 2013, they began a new bypass, 97 kilometers long, costing about 1 billion USD. The team called it surgery inside a blood vessel. They opened a new line within the old, keeping flow continuous. Completion is expected in 2025, after which new and old will run together. The Delaware Aqueduct has no scenic lookout and reveals no structure, yet it is among New York's most critical infrastructures. People use it every day without ever sensing it. It reminds us that true infrastructure is often invisible, and the continuity of civilization begins with currents we never notice. From mountains to seabeds, from beneath cities to the Earth's depths, these tunnels are not empty holes through rock, but traces of will. They let speed travel within stone and keep cities alive underground. Each advance is a conversation with the planet. Thank you for watching. If you enjoyed this, Don't forget to like, comment, and subscribe. Join us to explore more of this planet's hidden wonders.